It's over. So I think it's time for me to welcome you all and thank you for coming to the Birmingham Elixir meetup, wherein Alex Koutmos is going to talk to us about PromEx and whatever else he finds interesting. By way of intro, we've been doing this for around 6 months now, roughly monthly meetup. It should generally be monthly. I think we just missed a couple months at the beginning. And people are saying it's like the Austin city limits of Elixir meetups. Anyway, so that's my introduction to the group as a concept. And if does anyone else have anything they want to bring up before we hand the stage over to Alex? That's a big no. Hey, Alex, go.
Thanks for the warm invite. Let me share my screen and see if this works. All right, you guys can see my screen?
Yeah.
Yes.
Sweet. All right, so like Josh said, my name is Alex. Thanks for having me here at the meetup. Sorry I had to cancel last week. A blizzard knocked out power for my house for like 5 days, so it was kind of tough to hop on the interwebs and give a presentation here. But yeah, thanks for everyone for showing up today. I'm going to be diving into a library that I've been working on called Promix, and kind of the promise is that you can get Prometheus metrics up and running in 5 minutes or less in your Elixir app. So we'll demo that at the end, and hopefully my MacBook can actually do it in 5 minutes or less with with screen sharing and everything. But yeah, as a quick agenda, we're going to kind of talk about application system observability at a high level. The what and why of monitoring and metrics, why you would want to do this, and some pointers, the implications that monitoring has on the business and the engineering side of the house, and then some best practices and any patterns that you should try to avoid when instrumenting your applications. We'll also take a look at a high level at some of the community tooling, both external to the Elixir ecosystem and inside the Elixir ecosystem. And then we'll take Promex for a spin here and see how it goes. So before any of that, you might have seen me on Twitter or GitHub, or you maybe read my blog, but I'm currently a senior engineer at a company called Boulevard. We effectively offer a one-stop solution for salons and spas. So we take care of their like billing, customer scheduling, customer management, all that kind of stuff. Lots of Elixir. And actually the CTO of Boulevard was on the Elixir Talk podcast. So definitely give that a listen if you're interested about how Elixir was used to help catapult the business. I'm also a host on the Elixir Mix podcast, where Josh and I interview tons of people from the community. You've maybe seen my Twitter tips on underneath the My Elixir status hashtag. So if you've enjoyed those, you're welcome. If you feel like I'm spamming the My Elixir status hashtag, apologies. So every once in a while, I'll blog on my website. I've kind of put that aside for now as I'm working on Promix, but feel free to check out any Elixir content over there. And then I've also created a few libraries, so check out my GitHub, and hopefully something is useful to you. So observability, what is it, and how does it work? So in a lot of the SRE and DevOps literature, you'll usually see observability split up into 3 kind of pillars. The first of those being logs. So logs will be detailed information as to why certain events have occurred in your system. So maybe you'll log out like, hey, I couldn't talk to this external resource over HTTP, stuff like that. And logs are either structured or unstructured. An example of a structured log would be, let's say you're using JSON and you have a field for the time that the log was emitted, and then you maybe have like a message field. So you structure that log, and it's easy to parse from anywhere. You could also have unstructured logs, which are effectively free text. I would say you should probably use structured logs more than unstructured logs, especially if you're doing any kind of post-processing on those logs. I've seen in one too many companies people using these crazy regex patterns in like Fluentd, trying to parse these logs. It ends poorly, and you're in for a bad time if that's the route you want to go down. So that's the first pillar of observability. The next one is metrics. And metrics is the process of collecting time series data of your application. So as you collect these data points over time, you're also capturing some metadata on these data points. And you usually capture things like hardware utilization, API response times, database response times, stuff like that. The last of the three pillars is tracing, and tracing effectively gives you insight as to how certain events are transpiring through your system. So let's say you're in a microservices architecture and one service calls another. Tracing would allow you to see how long your event's taking to go from one service to the next, and kind of unroll all the way back. You could also do this in a single node application by effectively looking at the the function call stacks, and you can see how long you're taking at each in each function in the call stack. So once you have all three of these pillars stood up, you've achieved the coveted observability milestone. In reality, I don't see this a lot in a lot of companies. Usually, logs and metrics are achieved, and then tracing is put on the back burner. But the idea here is that all these tools are kind of complementary. Granted, they have a little bit of overlap here and there, and you can sort of abuse some of the tools to kind of make up for the lack of one of the other tools. But as a goal, you should really try to get as many of these pillars stood up in your infrastructure, so you can really get insight into how the application, how the system works, and just help out the business and the engineering side. So we're going to focus on metrics for today, because these other ones could be their own their own talks, and the library Promix that I'm working on is attempting to solve kind of this metrics problem in the Elixir space. All right, so what are metrics? So like I said before, metrics are the process of capturing data points over time, and we use these data points to monitor our systems and applications. Once you've collected these metrics, you could use them for alerting, debugging. If you're doing any kind of like performance enhancements, you can use this for before and after measurements. And then finally, you could also use it for business priority planning. If you're able to go back to the business and say the users of our system primarily use these parts but not these parts, that might be useful information for your your PMs and your POs, so they can do some kind of a roadmap planning. So why do you need monitoring? Well, you can't really manage what you can't measure, like Peter Drucker said. I've seen it in a couple companies where they don't have a decent monitoring or metrics solution in place, and it can be very, very painful to make either changes to the application from a performance standpoint, from a debugging standpoint in production. It's also very difficult to get a handle on things. So without some observability tools in place, it could be like you're flying blind. So definitely something you want to set up. So now that I've convinced you that you need monitoring and metrics in your application stack, what should you monitor? A good place to start, and some of the low-hanging fruit would be maybe your API endpoint response times and the response codes. Are you kicking back 500s, 400s? Ideally it would be 100% in the 200 range. But that's important to keep track of, because that's your boundary into your system. So you want to know what your users are experiencing. Hardware utilization is also another key point to keep an eye on. So you want to know if your VMs are running out of memory, if your CPUs are pegged at 100. All important stuff to keep track of. If you're using any kind of messaging technologies like RabbitMQ, you also want to keep a track on maybe some of these primary queues that your applications rely on. If the queues are building up, maybe you need to horizontally scale out the workers. Maybe that's acceptable if you don't have any really tight SLAs with your customers. So all things that you need to keep tabs on. And then if there are any key performance indicators or KPIs for the business side of the house. So if let's say the marketing department runs a campaign and they're expecting tons and tons of signups, it would be really great if, you as the engineers can come back and say, hey, these are how many signups we got after this campaign, and we could, very clearly see the spike in the graph. Or, nothing happened. Maybe that was a very poor campaign and a waste of money. But either way, it's very good to keep tabs on these things. So on the business side of the house, monitoring really comes down to a better user experience or better customer experience. Because if you're able to alert on events happening that you need to be alerted on, you can immediately go to work on fixing those problems, as opposed to waiting on, say, like your customer support team, waiting for an email to come in from a customer and then deal with the problem. So you're able to react to customer issues as they occur, as opposed to waiting to hear from customers. Then it also gives you objective data into how your users are interacting with your application. While you could send a survey out to all of your customers, who knows how many are going to respond? Who knows how much of that information is actually going to be accurate? It's better just to look at your actual application and have that surface usage metrics. So these are all good things for conversations you should have with like your POs and your PMs, and see what's important and what needs to be captured. From the engineering side of the house, this is super important because it acts kind of like a first line of defense for debugging production issues. It usually gives you insight as to what's going on at a high level. For example, let's say you have some metrics around HTTP endpoint response times and status codes. If you're getting 500s from one particular endpoint, you know exactly where to start your triaging and debugging. You could start right at that endpoint, and your metrics and monitoring solution kind of point you in the right direction right from the get-go. So that helps lower the amount of time it takes to actually fix problems. If you're doing any kind of performance testing or optimizations and stuff like that, you really do need a monitoring solution in place, because there's no good way to really quantify what changes you've made if you don't have numbers to quantify. Did you make it better? Did you make it worse? So definitely need something to take proper measurements. And again, if you're doing any kind of architecture planning, you need something to quantify your theories and decisions. If you're unable to point out what the bottlenecks are in your system, how can you effectively plan out how you need to change this architecture? So some best practices for getting started. A good starting point is capturing things from the user's perspective. So endpoint status codes and response times are a really good place to start. Ensure that your data point label cardinality is low, and this kind of depends on your time series database that you're leveraging. For every measurement, you'll also have labels that'll be kind of like your metadata for that measurement. Some time series databases don't respond nicely to high cardinality values. Cardinality means like for one particular measurement, the metadata can have a wide range of values. So say like a user ID, that could be effectively unbounded, versus if you have like the user type, which is a bounded field, like admin, super admin, and basic user. So you want to keep cardinality low as best you can. Another best practice is only alerting on what's actually important. If everything in your system creates an alert and you have a Slack channel with 99 plus messages every morning, no one's going to care. No one's going to read these things. You're just going to flood the team. So if everything's an alert, then nothing is an alert. So you really need to be cautious about what you're alerting on and what may be maybe what you're not alerting on. So some anti-patterns. You definitely don't want to have monitoring in place just for the sake of saying that we have monitoring in place. I've actually seen this in a couple places where they'll subscribe to some SaaS platform, have an agent installed, and then not really develop that monitoring solution, not adding any new metrics, not adding any more dashboards, not really using it to its full extent. So that's something you want to be wary of. Definitely put the time up front. Whatever solution you end up choosing, make sure you give it the time it needs to really develop it. Another anti-pattern is using monitoring as a crutch as opposed to fixing the root cause. So like if you have, let's say, a memory leak in an application and your monitoring solution is now turned into something that's just used for alerting you at 5 p.m. every day to restart the server so you can start back at a lower memory usage, that's not something you want to do. You definitely want to fix the root cause and not leverage your monitoring solution just to help you kind of limp along. All right, so that's kind of a bit of the theory out of the way. Is any questions on that so far? Or? All right, I'll keep going. So as far as time series databases go, there are generally two styles. You have the push style and the pull style. So InfluxDB is a push style time series database. In this diagram that I have here, we have 3 applications, and all 3 of those applications are configured to push metrics to InfluxDB as events occur in those applications. When you go to surface them as the user, you would log into your Grafana dashboard. Grafana would make influx QL calls to InfluxDB to then surface the data that you need to visualize. In a pull style metrics setup like Prometheus, your time series database will actually reach out to all of the services at a regular interval, and it'll actually hit an HTTP endpoint, which will return kind of like your aggregated metrics for that time span. So if, let's say, our Prometheus instance is configured to scrape all these Elixir services every 5 seconds, those Elixir apps would be aggregating those metrics, and then they would get scraped every 5 seconds. One of the drawbacks there is the resolution of your metrics is limited to that scrape interval. So if you're scraping every 5 seconds, those are the only time intervals that you have data. One of the benefits there is you could scrape and collect a ton of metrics in Prometheus, and given that you're aggregating over discrete time intervals, it's pretty efficient at storing all that information. So you can kind of monitor and collect metrics at your heart's content and not really worry about the operational overhead of running a Prometheus instance. So diving into the Elixir side of the house, there's a GitHub organization called Beam Telemetry, and that has a lot of the kind of first-class libraries in the Elixir ecosystem for monitoring libraries and applications. One of those libraries is called Telemetry. You've probably heard of it. It's in a lot of the really popular Elixir libraries. I think that's kind of set the tone for what utilities and libraries will use to monitor our applications as well. So Telemetry itself is currently used by 107 other libraries, including Phoenix, Ecto, Absinthe, Broadway, and Oben. And the nice thing about this community tooling is that we have a consistent interface across all of these really popular libraries, and it's very easy to surface operational metrics. In other language ecosystems, every library, every tool has its own way of doing it, and it can be a real pain in the butt to kind of figure out what's actually going on inside of these libraries. So we're pretty lucky here in the Elixir ecosystem that we have this community tooling that's both really simple but ridiculously powerful at the same time. So as a very quick overview as to how telemetry works, it's effectively like a pub sub system, but synchronous. So your libraries will emit events. So in this case, I just took a snippet out of Broadway here. Broadway will emit a Broadway processor start event. So this is your event ID, and it'll attach measurements and metadata to that event. And if there's nothing attached to those events, it's effectively a no-op. It won't call anything. But if you've attached your own handlers to those events, like I have here, for example, given my debug handler for my as my ID for my telemetry handler, I'm attaching to the Broadway processor start event, and then here's my callback that'll be invoked whenever this happens. And then whatever you do in this this function block is totally up to you. If you want to publish the measurements or the metadata, totally up to you. There's no there's no limits there. The only thing you need to be cautious about is this is a synchronous call. So if you perform any blocking operations in here, you're effectively stopping execution in the library. So just something to be cautious about. So built on top of telemetry is another library called Telemetry Metrics. This is also part of the Beam Telemetry GitHub organization. But Telemetry Metrics offers a convenient way of generating metrics from these telemetry events. So as opposed to you writing that, that function block every time to generate metrics, Telemetry Metrics offers that abstraction of connecting to or attaching to those telemetry events and then generating metrics out of those. So in this example, this is actually taken from Promex. I'm attaching to the query event from Ecto, and then I'm also grabbing out the queue time. In other words, how long did the database connection sit in the pool and wait for wait to be executed on. And then given all these options, it'll generate the appropriate data point for Prometheus and Influx and other ones to pick up. So telemetry metrics itself doesn't make any assumptions as to where this data will end up, but there are other exporters in the Beam telemetry ecosystem. So there's one for, I think there's one for StatsD, which is Influx, and then Prometheus, which is what I'm using. So working our way to the top of the kind of abstraction hierarchy, I've built a library called Promex that sits on top of all these other Beam telemetry libraries. And what it attempts to do is create a plugin style library where, depending on what the libraries you're using, let's say Broadway, Phoenix, and Ecto, you would pick up the appropriate Promex plugins, use those, and for free effectively get all the metrics collections for those libraries, and then accompanying Grafana dashboards. So whatever metrics Promex is collecting with those plugins, you would have a Grafana dashboard that, with no configuration, presents all those metrics. And the other nice thing about Promex that I've put together is that it interfaces with Grafana via its HTTP API. So when Promex starts and it brings up its supervision tree, one of the configuration options is to start a Grafana client that will automatically upload all of your dashboards to Grafana for you on app init. And the nice thing there is your dashboards are now part of the code base, and so they're kind of treated like a first-class citizen. Whereas before, you would kind of leverage Grafana, kind of like you would like the AWS console. You'd go there, you make some changes, and then those code changes are never really kept track of anywhere. So I feel like Promix does for for Grafana what like Terraform say did for the AWS console. And then Promix itself supports a couple different or a few different types of metrics. You have your polling metrics, which are data points that you're capturing at a regular interval. You have event metrics, so as events occur, you'll capture those metrics. And then you also have manual metrics, which are metrics that you get only once on app init, and then any other time, let's say that you manually invoke a manual metrics collection. So like, let's say you're doing hot code upgrading and you want to capture those metrics every time you hot code upgrade. You would use manual metrics there. So the goal of Promix is to kind of go through that list of 107 libraries on Hex, kind of get all the popular ones in a priority queue and just start making Promix plugins, and then accompanying Grafana dashboards for each of those plugins. And the main point is to make it as easy as possible to instrument your applications using these abstractions that we have for us in the Elixir ecosystem. And then it also provides a nice workflow for actually getting these dashboards to Grafana. So it's really meant to help streamline that observability workflow. So with Prometheus and Grafana, you could develop on those platforms locally. They're in Docker containers, and as your features and applications get deployed, they can move up the various environments from dev to stage to prod. And so those dashboards are treated like a first-class citizen. And then it's also meant, or it also aims to provide an easy way to have you write your own Promix plugins for your application needs. So like, let's say you need to keep track of some business KPIs, let's say maybe user signups. You would create a Promix plugin that keeps track of some user metrics. So it's extensible. It's not meant to just take care of Phoenix, Ecto, Broadway, etc. You're also supposed to use this toolkit to create your own metrics, and Promix will take care of those for you. So some non-goals. I've been battling with how much configuration I want to have within Promix. I feel like I found a decent balance now, where I offer some high-level configuration. But if at any point you find that maybe the plugin and the dashboard don't fit your needs, they should be they're really easy to fork. Just copy and paste the plugin and the dashboard. You can make your own changes to them, and you could have Promix point to your forked versions as opposed to like the first party Promix versions. So that's kind of the balance I've struck, where it's like have some sane defaults, provide configuration for the things that I think most people will need to configure, and then just kind of cater it more towards ease of forkability. I also don't plan to support any other time series databases at the moment, or else I'd probably need a new name for the library, given that Prom kind of ties me to Prometheus. But that aside, it'll require a lot of work in the dashboards, because now I need to convert all those PromQL queries to, say, InfluxQL or TimescaleDB, so Postgres calls. So it's a lot of work to support other time series databases. So probably not a goal for now for the foreseeable future. So currently the status of the project is that it's in alpha. So I've completed an application plugin, a Phoenix plugin, and a Beam plugin and an Ecto plugin. And all 4 of these plugins all have accompanying dashboards. I actually finished the Ecto plugin this afternoon just for this this talk, so just in time. The goal is to try to get a stable release by, let's say, middle of January. And the last thing I need to do before doing that is I need to be able to templatize the Grafana dashboards. Some of the dashboards currently have some configuration hard-coded, and what needs to be done is, prior to uploading those dashboards to Grafana, there just needs to be some like last mile adjustments. So it'll probably involve storing those JSON definitions of the Grafana dashboards as like EEX templates, substituting a couple of variables, and then publishing it off to Grafana. And the nice thing about that is it opens up the ability to have dynamic dashboards. So like, let's say you want to have a dashboard that that sets some like alerts and limits based on the platform that you're running on, or maybe some like Beam flags that you have set. Your dashboards can reflect those changes kind of on the fly as you deploy, as opposed to having them hard coded in the dashboard. And with that, it is demo time. Anyone have any questions?
I'm excited about a demo.
All right.
Yay, demo.
All right, here. So let's see. Let me move this Zoom stuff over here. Okay, so you all can
I'm also
see.
excited about not having to manually do all the stuff I've done for this sort of thing before.
Yeah, that was my pain and frustration. Whereas like every time I wanted to set up Prometheus and Grafana, it was always like a 1 day thing for Prometheus and then like a 4 day thing for Grafana, and I never want to do it ever again. So that's my goal with all this. All right, so there are 2 demos here. The first one will be starting a vanilla Phoenix app and starting from scratch and getting Prometheus metrics up and running. It won't be super slick because it's just going to show you the Prometheus metrics dump, which is just a text output. But that should be achievable within less than 5 minutes. Then the second demo, I'll actually show you one of the example apps that comes bundled with Promix, which gives you a full Docker Compose stack with Grafana, Prometheus, and Postgres, and that shows you end-to-end uploading dashboards and everything like that. And I also have a stress test script that we can run and watch the graphs dance. So let's, does anyone want to start a timer and see if I can do it in 5 minutes? All right, I'll trust somebody started with. All right, so we're going to start by making a new project called Cool Project.
Should I loudly count while you do this?
If you want to. As long as you're muted, that's on you. So I'm going to start a new Phoenix project. I'm going to omit Webpack because that's going to take us over our 5 minutes here. If I have to download, 1 gig of node modules. While that's running, we're also going to start Postgres in the background since our app is going to have Ecto. I should have done this on my Linux workstation. This MacBook is I can feel it heating up already.
Get out and push.
Any questions while I wait for this, or?
I think this is the first time I've seen you wear a button-up shirt. Was it just for tonight?
It was just for you guys.
This is a formal affair.
All right, so we go to cool app now, or cool project. We're gonna add Prometheus or Promix. And I just published, I think 0110 alpha this morning. We're gonna mix deps and get that. And I've created some nice mix tasks to generate a lot of these config files for you. So it should be stupid easy to get started. So Promix will create your Promix module. It kind of follows the repository pattern where you create a Promix module for whatever metrics you want that instance of Promix to capture, and it'll start its own supervision tree. So you could actually, in theory, have several Promix entries in your supervision tree, and have each Promix instance capture its own metrics. So like let's say you have one instance of Prometheus in your cluster capturing business metrics, another one for engineering metrics. You could very easily kind of separate those two. So we're going to open up that file that it generated dynamically for us. Luckily, I was smart enough to give myself instructions here. So if I open application.ex, we're going to add that to the top of our supervision tree. And the reason that we add it to the top is repo will emit telemetry metrics on init, and we want to capture those. But if Promix is started after that, we'll miss those init events. And then the last thing we got to do is we have to go to our endpoint.ex file and stick that entry in there. So now we have a plug in our pipeline that will actually serve those metrics. And the only option we need to send to that plug is what Prometheus or what Promix module do we want to surface the metrics for. Then if we do .setup, that'll, oops, help if I was in the right directory. All right, so I think if we do that, $4,000. So I'll refresh it 2 more times, because then if we go to /metrics, there are all our Prometheus metrics. And given that this is a live view app, if we go to our channel join events, we'll see that we actually, I went once and then refreshed 3 times. So that's our channel joined events. So without any work, I now have Phoenix channel events, Phoenix HTTP events, Ecto event metrics, plenty of Beam metrics. We have active tasks, garbage collection stats, atom counts, ETS table counts. How long did that take? Did anyone time that? Was that 4 minutes?
It was like 4 minutes.
4 minutes, yeah. So that's kind of the goal of Promix, is with minimal work you can get all this up and running, and it's ridiculously easy. So that's the first demo. So we'll kill that guy. We'll kill this guy. All right, so then for this one, we're going to go into our example application. And this is something that comes in Promex. If you ever need like, a sample Docker Compose stack for getting all these things up and running, feel free to just rip out what I have in the example app, and it should get you well on your way. So what we're going to do is run Docker. So we're going to start the stack, but scale down the Elixir app to 0, mostly because I want to get into Grafana, make some changes, mostly just generate an API key, and then use that key inside of the Elixir app. So I'll show you how that's done, and then we'll see how on application init we'll upload all of our dashboards to Grafana without any interaction from us. So Grafana is on localhost 3000. So as we see here, no dashboards, so I'm not lying. I'm not trying to pull any fast ones here. So if we go to API keys, I'll say this is for Promix. I'll say that this is an editor. So this is our API key now for Grafana. So once we give this to our application, it'll be able to communicate with the Grafana API. We can actually tear down the stack now. If we go to, I think it was this guy. Yeah. All I'm doing is setting this environment variable with the token that I got. And if we, just so you can see where it's used. So this Grafana token environment variable, if we go to dev.exs, we'll see that it's looking for that over here, the auth token. And this is just some configuration that you pass to Promix. I didn't have to do this configuration with the vanilla Phoenix app because I didn't need to set up Grafana. By default, it's disabled, and it's you don't actually need any configuration. The defaults will get you there. So yeah, with that, I think I saved that file, right? Yeah, I saved that. So now if we run the whole stack. All right, so some things to point out. In the logs over here, we'll see that Promix has told us that it was able to upload the dashboards that we have configured. So like if we go to lib Promix, this is our like the Promix repo module, if you will, where we define the plugins that we want to enable and the dashboards that we want to upload. This list will mirror what Promix attempts to upload on start. So we have our application dashboard, Beam dashboard, Phoenix, and Ecto, or those plugins, and then we have those accompanying dashboards. So if we go back to Grafana, whereas before we didn't have any dashboards, we now have 4 dashboards. So we have our application dashboard, which is just static information on the application. So we see how long it's been up, what the name of the app is. I think I've spoofed the Git SHA for the app, but you can set that as well. The version, and then how many modules our own app has loaded, and then you have information on all of your dependencies. So you could see how many modules they have loaded, the versions they're at, and whether those apps have been started. Go back to manage, we could see Beam dashboards. So this gives us stats on the Beam itself. We see how much memory it's used, atom count, process count, all that good stuff. And again, this was out of the box. I didn't have to do anything. I'm just I'm merely loading the vanilla dashboards that come with Promix. So let's think if I run my stress tester now, we should be able to make these graphs dance a bit, and it should be a bit more interesting than just looking at flat lines. So the stress tester that I've written will just make a bunch of HTTP calls to the app. It's mostly just like deleting rows, adding rows, updating rows, stuff like that. Just something to exercise the app a bit. So you'll see logs here are getting dumped. That's a good sign. So if we go to Phoenix dashboard, let me actually zoom into the last 5 minutes so we get some higher resolution here. But we'll see that we have some nice histograms here for how long requests are taking, the response payload, the codes associated with these HTTP calls. So here we're getting 200s from the user's endpoint. We're getting 200s from the post call here. We're getting an aggregate view of all the calls across our system, whether they're in the 200 range, 300 range, 400 range. I actually think if I go to the root of the app, I actually inserted a bad arithmetic expression error on purpose, just so we could see some 500s. So if we keep on refreshing, you should actually see a line pop up here with some 500s. Let's see if that actually shows up. Yep, there's some 500s. So those are the Phoenix dashboards that you get. And I've separated them between HTTP metrics and channel metrics. So that's what's down here. But if we go, let's say, to our Ecto dashboard, we can see all of the all of the events hitting the database. So what kinds of actions is Ecto performing on the database? Is it a begin, which is a transaction? Is it committing, updating, inserting, stuff like that? So that's kind of Promix in a nutshell.
This is really, really cool, Alex.
Oh, thanks. Any questions?
Yeah, how would it work with like a distributed application?
So like, let's say you had like multiple instances of your app.
Yeah.
So when Prometheus scrapes your configured endpoints, it'll also attach its own kind of like out of the box labels to those data points that it captures. And two of those data points that it adds are the application instance and then the job. So in your scrape config in Prometheus, you define what the job name is, and then every instance of that job, it falls underneath this application instance. So I've actually gone through and already parameterized all these GraphQL queries for you. So if you decide to use PromEx, all this is already set up, and let's say you have a microservices architecture, 5 apps are all using Ecto, and you want to see one particular app's instances metrics, you would just select them from these two drop downs, and you're off to the races. I think the stress tester is done here. Yeah, we're good.
So what kind of help do you need to get it to like 1.0 faster?
So templatizing the dashboards is high on the list. I think as like an initial release, the 4 plugins that I have are probably sufficient. But yeah, I mean, shortly after the 1.0 release, it's really going to be sitting down, figuring out which plugins to write next, and then just kind of plugging away at those. But yeah, as far as what's left to get to that 1.0, I think it's just templatizing the dashboards.
Now, if you had, I think Anderson was probably pointing at this question a minute ago, but say if you have a cluster of the same app, which is very relevant to what Anderson and I are working on, the dashboards for that, how will they see multiple nodes that are running the same app, and how does it all get aggregated?
Yeah, so in your, actually, let me see, I should be able to pull it up here. Yeah, so in your Prometheus config, and this is going to depend on how you deploy your application, but you may have to set up some sort of service discovery in Prometheus, so it can dynamically find all the versions of your apps in your cluster. Prometheus itself has a bunch of strategies out of the box. Like if you're running in AWS, for example, you can use like the EC2. I think it's like the EC2. What was it called? There's a way of like pinging the EC2 API, finding all the instances of an app using like labels and stuff. And so you could dynamically populate this scrape configs value at runtime in your environment dynamically. And that's what you would have to do in a real production environment. This is very much just local development stuff. And if you're running Kubernetes, there's also like a Kubernetes service discovery utility. But what you would have is you would have like your job name here for whatever job you're attempting to scrape. And then via that service discovery mechanism, you would find dynamically all the instances of that app to scrape. And then as the app is scraping them, you're going to get these things populated here. So if you see here, the job name is Elixir app, that's here, Elixir app. If I had like 2 other apps, those would also show up on this list. And then for every instance of those apps, you would get that list over here.
Okay. So, right. So then you just have the, and back on the config, which part, so is it the before the 4,000, does it have meaning there in the targets?
This is the port.
Just as a,
that's just the port that it's running on.
Okay, so that actually is really the port then. So then Elixir app is the Elixir app colon 4,000. Elixir app's not the name of your host here, but it's the name of.
So if you look, let me see here. So that Elixir app value will align with this here. So in Docker Compose, it's not localhost. It's the actual like the name of the service that it's called. So like if I go to my where was it? Config. Yeah, down here. So the host for Grafana is Grafana colon 3000, because in my Docker Compose setup, Grafana is just called Grafana and it's running at port 3000.
Okay, right on. Yeah. Yeah. Okay. That helped connect the dots there. Thanks.
Cool. Yeah, it's a little weird when you think that the database itself, the time series database, is the one reaching out and collecting the metrics. So it's like if you're comparing Prometheus and Influx DB or some other push style metrics system, there is a bit more operational overhead put on you to set up like that service discovery and the scraping and stuff like that. Setting up something stats D based is a lot easier because you literally just give every app the host and some secrets and that's it, you're done. But Prometheus usually requires a little bit more work.
Let me ask a follow-up here, and maybe you answered this and I missed it. If I've got 2 instances of my apps on 2 different nodes, distributed Erlang, I'd love to see 400 responses, and I don't care which node actually sent that. I want to see the aggregate of those. Is that something that's easy to set up?
So I currently don't have it configured that way. But I definitely could very easily add something like that. Because like right now, let me make these editable. So like, let's go to the memory usage, for example, and we edit this dashboard, right? I could very easily have like a global dashboard for all instances of the app and don't narrow down by job or instance, and then just sum up all the values. So that's very easily I could very easily add that. And maybe that's something I stick, over in the like overview section. It's like system-wide health, and it gives you some high-level stats on all instances of the app.
Yeah, that sounds really helpful. Yeah.
Yeah, thanks.
Yeah, and this is also where the templatizing of the dashboards would also be useful, because then you can configure as a consumer of the library what portions of the dashboard are even relevant to you. Like maybe you don't need the distributed overview. Maybe you do want it, but it would be nice to kind of omit parts as you need them.
Given that's one that you called out as being a need at this point, how would you even get started on that? Would you be able to hack around just a little bit at it and show us even what part of the code you're talking about?
For the templatizing?
The templatizing the dashboards.
Yeah, I can kind of give you some of my...
Give us a butcher's view of the
yeah,
thing.
So I've been battling with how exactly I'm going to do it, but I think, let's open up the PromEx module here. I think what I'll end up doing is probably editing or probably adding like an options field over here. And so this would be the project or the OTP app that you want to look in the priv dir for. This is the file in your priv dir. And then maybe this last argument is a keyword list. And perhaps it's like all the assigns. So like if you're thinking about like an EEX template, you would have like assigns. And maybe you have like OTP, app, some app. Maybe you have like some dynamically generated values. Like maybe I've configured the beam to have a certain atom limit, and maybe maybe that's dynamically generated, so on and so forth. And then I would pass that keyword list over here, and then in the whatever's consuming this dashboards function would pattern match on a 3-element tuple. If it sees a 3-element tuple, it'll look for a application.json.eex file in the priv dir, and then apply all those assigns to that dashboard. If it sees just a 2-element tuple, it's effectively told that, hey, this is a static piece of JSON, just upload the whole thing.
Yeah,
So I think that's how I'm going to be approaching the problem. I don't have any like branches or anything with it running, so nothing to show at the moment.
Yeah, cool. Thanks.
Mm-hmm.
I'm also curious. I'm still new to this. We kind of got this going in production, a few weeks ago, getting live dashboard going.
Mm-hmm.
And that's given us some great insight into our system. It's even something that our product managers can look at.
Mm-hmm.
Is there any interest in servicing some of the Promex dashboards in live dashboard instead of this other Grafana host?
So that's a really good question. Actually, something that I've been it's actually on the to-do list. So Promix isn't meant to like directly compete with live dashboard. Live dashboard is great for that on demand. I need to just look at the logs and the metrics type of thing. But live dashboard itself doesn't actually persist this data anywhere. So like once you refresh the browser, your metrics are gone. So Promix's primary goal is to get this stuff into a time series DB, namely Postgres or Prometheus, and then you can have this stuff persist for months at a time. Where I'm thinking about having some sort of a live dashboard integration, and I haven't even started experimenting with this idea, but it seems possible. I think. Okay, so this project was generated with the telemetry module. So this module gets generated from the Phoenix generators, and this definition actually looks very similar to the Promix definition for how I define metrics, given that they both use that telemetry metrics library. So under the hood, Phoenix dashboard uses the same stuff that I'm using. So in theory, it should be possible to rip out all the things that I have in in Promix, like when you define your plugin definition and be able to inject this into Phoenix Live Dashboard. So again, I haven't experimented with it, but it should be a pretty easy thing to get all the metrics out of Promix and surfaced on Live Dashboard. But it's on the to-do list. I haven't experimented with it yet.
Okay, cool, great. Yeah, I've, like I said, we've just been playing with it, and yeah, it'd be cool if we could persist things longer, but yeah, even if we can't, we use hot deploys, so actually our services are up a while, and yeah, okay. I'm glad it's on. I'm glad it's on the
Yeah.
to-do list.
Yeah, and I mean that's the nice thing about all these tools leveraging the same like Beam ecosystem tooling, where there should be some cross-pollination there. So I think we're pretty well positioned here in the the Elixir ecosystem to do some pretty cool stuff in the space.
Yeah, there's so much cool stuff going on. Yeah, and this is adding to it. So thanks.
Oh, you're welcome. Any other cues or?
I have nothing.
I'm back to beating the same thing again, the same drum. Just thinking about different usability things on the front as far as the cluster ideas and what you're talking about. We run into a similar problem in Wombat as we use Wombat, and it has a very single user sort of view once you're drilling down into anything. And I think that's actually a feature they're looking to implement now is to have a sort of an aggregated view of lots of things. And so that's definitely an easy path to get into, and then you didn't even realize you were down that path, and you're all of a sudden you're boxed in. And so so the idea of having either cluster or even subgroups within a cluster, would be a really interesting way, because some systems will have things broken up in partitions by a group of servers that do a job, or a group of servers that are located somewhere, or a group of servers that are but they're all playing.
Yeah. So
playpen.
Part of the part of the templatization effort is also to give all these dashboards unique IDs, because you might have like 3 applications that have nothing to do with one another, but maybe all leverage Ecto, and you don't want those dashboards stomping on one another.
Right. Okay.
Another thing is, let's say you want to, we'll discard my changes here, but if we go to, managing my dashboards, maybe you want a version of each of these dashboards in, their own folders. Maybe we have like the user service here. Go back here to dashboards, and let's say I have, this is also an Elixir service, and I want my own versions of all the dashboards in this, user service directory in Grafana. So these are all things that are possible from the Grafana API. I haven't implemented those bits yet, but that's also part of that templatization effort, where on the fly we can determine that I want this Ecto dashboard in the user service directory, and then when maybe the payments service comes up, it also publishes its own Ecto dashboard to the the payments service directory. So yeah, there's quite a few ways to do that, and I think for for aggregating all the instances of an app, I think it's going to depend on the Prometheus job, and then just kind of sum up all the instance values. And then maybe perhaps just have some overview panels here to kind of guide you in the direction, where it's like maybe you're getting 500s somewhere in the cluster, and then you can drill down further and figure out where you're getting your 500s or something.
Cool.
Did that answer your question? It was kind of
I don't even know if I had exactly a question. I'm just sort of this is just getting me thinking about all sorts of things I wasn't able to think about, an hour ago.
Cool. I'm glad. That's the whole goal.
Yeah. One was you were talking about tracing earlier. Do you have any thoughts on what your will there be another library that hangs out here that will kind of hook into there? Because at the point you're doing the tracing, you're definitely talking cluster land, or at least you could be. And so that might be an interesting. Yeah, I don't even know what that would look like.
Yeah. So there's. Oh, go ahead.
You go.
So there's some work being done in telemetry, the library itself. So I actually wrote the PR for the span function in telemetry, and I think that might be like the initial work for how we get spans in Elixir app, and spans are effectively what you need for tracing, because you need to know this operation is spanning this time frame. Here's the start event, here's the correlating end event. So there's initial work being done in telemetry to support these things, but I don't think it's at the point yet where we can easily do it.
I was wondering if you're in the land of Zipkin there, and how if Zipkin is the analog to Prometheus, or I don't even. I'm sure these are things that you've been thinking about, and I'm just now forming questions. And so
so I've played around with Zipkin before. I think, what was it? It comes with Istio. If you deploy Istio to your Kubernetes cluster, you can get traces internally in the cluster. Like if one service calls another one, Zipkin comes with Istio, so you can see all that. But I haven't like aside from the the network layer, getting traces there, I haven't set up anything at like the application layer to get traces from this function call took this long, and then it called another one and it took this long, and then kind of seeing that waterfall. I haven't gone down that route yet.
Gotcha. Okay. Yeah.
But I mean, it would be interesting to get that. I don't know if that would live within Promex.
It seems like it'd be a kind of a peer project of it, one that would kind of play with the same APIs, the same design philosophy.
Mm-hmm. Yeah, that would be really cool. Yeah, I would. I've actually tried joining the observability working groups a couple times, but I think the few times that I tried joining the Erlang observability working groups, maybe the meetings weren't happening or something. So I was the only person on the Zoom call. So
that means you own it.
Yeah, right.
You're the chair of the committee now.
Yeah, my impression is they really want people. So if you want to volunteer, they would be happy to have you.
Yeah, sure. I'd love to hop in on some meetings. And another thing that's been on my mind is how do I get this to the point where it's easily consumable from an Erlang perspective? Because right now it's very easy, as you guys saw, to get it up and running in an Elixir app. I don't know what the story looks like for actually getting this up and running in Erlang, and maybe maybe there's just maybe we get some plugins for the Erlang community as well. Maybe we have like a cowboy plugin or something like that. So yeah, all interesting stuff.
So if I wanted to get alerts based on this data, is that something that Grafana gives me out of the box?
Yeah. So if you go, I think if Grafana's changed where they've put their things. I haven't set up alerting in whatchamacallit, Grafana 7, but I think if you go to it should still be here.
Oh, cool.
Template variables not supporting alert queries. Maybe not. Yeah. I'll have to take a look at this because that's also on the roadmap for perhaps adding alerts that you opt into over here. But usually there's like a drop down here. It's like, where do you want to send your alerts? It could be like Slack or PagerDuty or stuff like that.
how are you gonna, since you're like coupling like PromEx to the creation of dashboards, how are you gonna couple updates to dashboards with like semantic versioning?
So I mean, if you update the version of Promex that you're using, let's say you go from 1.0 to 2.0 or something like that, you'll get all the new dashboards that come along with that updated version of Promex, and then on app init, those dashboards will get automatically uploaded. I was going through the Grafana because I mean all this at the end of the day is just a JSON definition. Like if we go to JSON model, it's like a couple thousand lines of JSON that actually generates these Grafana dashboards. And this is what's in Promex, is these dashboard definitions that I've pieced together. And I've dug through their data model. It doesn't seem like they have anywhere in this JSON definition somewhere where you can put your own like book tracking metadata, which has been a bit of a pain point, because it would be nice to kind of maybe stick like you said, like a version somewhere in the JSON definition here, so that I know on the Promix side, like, hey, I've uploaded, 1.0, and maybe that's part of the output. It's like, hey, you've updated this dashboard from 1.0 to 2.0. Then, I mean, not every release of Promix is going to have every dashboard changed. So like maybe one version has a couple updates to the Ecto and Phoenix dashboards, and then another one has Beam updates. But yeah, for now it's just kind of every time the app inits and it talks to Grafana, it uploads the latest version.
And it's maybe not a problem that you solve, but like you're accepting as a user, you're accepting one that like the API changes, but also that the dashboard could change.
Yeah, because they are coupled to one another. Like if I make changes to the Ecto plugin as to how it surfaces metrics, you need the dashboard updates as well, or else it may not be plotting properly or even plotting at all.
Got just sort of a vague "there be dragons" kind of a thought that's in my head about multiple versions of an app within your cluster, and if you can think of any places where that might blow things up. Because in that line we have the reason I'm thinking about that more directly is we've managed to blow up Wombat with that very thing, and so now we have a release cycle where we deal with Wombat, where we take Wombat down, do a release, and then bring up the new version of Wombat. So if you have so you can end up getting into a real tricky spot there. And I don't know if this would, I guess it maybe wouldn't, because it's entirely just JSON that's going back and forth, and you're not actually doing any beam shipping. And
yeah, so I have thought about that problem. Like if you have, let's say, 5 instances of the app, and on init, all 5 of those will upload their dashboards. It'll be last right wins.
Oh, okay.
So that's also part of the templatizing effort, where I'm thinking about prefixing. Actually, let's open up one of these.
Yeah, if you were able to stick to the version of that beam that you called let's see, earlier you had a spot where you listed the name of the beam that was going to own the privileger.
Yeah. So
if it also grabbed the version or
there we
something from that same guy, then
yes. So the idea to mitigate that issue is to templatize the dashboards and to prefix all the dashboards with the OTP app that they're associated with. So for example, this one's like the web app OTP app. So if we go to my Beam dashboard definition, there's a UID field, and this will eventually become a part of the EEX template, where I would have like a prefix here that says like OTP app or something, and then this would prevent you from stomping on another app's Ecto dashboard. But then within your own cluster of apps, it's kind of assumed that each version of the same app is the same. So if you have like a payments app and you're just deploying 5 instances of it behind a load balancer, it's kind of assumed that all 5 instances of that share the same code and the same dashboard. So last write wins doesn't necessarily matter there.
Yeah, except during like red-green deploys.
Yeah, then half your cluster would be a version and half would be another version.
Yeah, there you would
you-
have there you would have some issues.
And of course, that's going to be a thing that maybe another community wouldn't hit as hard, but on the Beam side, that's more of a common.
And I mean,
kinda-
this is where it would be really helpful to have somewhere in the Grafana spec, somewhere to stick this metadata.
Yeah.
Because like there's not a lot of places for me to add this kind of information, but I didn't even think about blue-green deploys. So that's a good point where you'd be in a weird state of
Yeah.
yeah.
I think you showed this earlier where you're passing a token. So you can give tokens to. You were basically using a bearer token, is that right? So you could call back into your app. So you would actually have you could auth and say, okay, I'm willing to give this thing.
Yeah. So that this
telemetry
line.
data.
So this is the token for the app to talk to Grafana. So this is a Grafana generated token.
Oh,
and
okay.
effectively gives my app the ability to publish new dashboards to Grafana.
Okay, and how about the other direction? Since Prometheus is pinging us, is pinging your at port whatever on your Phoenix app to say, hey, give me data. How would you wire up the security on that so that you don't let just any Yahoo that comes and asks at that endpoint to get all your telemetry data?
Yeah, so that's a really good question. So I've actually written 2 things to deal with that issue. So one, there's that plug that I added here in endpoint.ex. Where is it? Yeah, there it is. So this is what's surfacing your metrics. I have actually written another library called unplug. And I think in the docs, I actually point you in this direction. But if you look at unplug, it allows you to essentially disconnect the plug from the pipeline if certain parameters are met. And I think actually, okay, maybe I don't have it, but you could set it up so that, let's say you've told your Prometheus instance that it needs a certain token and your Elixir app is configured with that token. You would use unplug that says, yeah, there we go. Request header equals. So you would say that like, does the authorization header equal some configured value? If it doesn't, then skip this plug. And so that's what this library does. So I push people in that direction for when they want to do authorization for the Promex plug. But then there is also a request to set up a standalone HTTP server. I can't remember who made the request, but someone was saying that their app doesn't use Phoenix because it's like a queue worker app, so there's no reason to use Phoenix. But they still wanted to surface metrics. So I've actually created. Let's go up a couple directories. So I've actually created a standalone HTTP server within Promex. And if I remember where I put it, there's metric server. And this one, since it doesn't leverage Phoenix or any of those things, you can also configure it for a bearer or a basic token if you're using the standalone server.
Right on. Okay.
So yeah, if you go the standalone server route, configuration is there for you. If you're using the plug, use unplug to configure authorization. I may just pull that into the Promex plug just because that's a pretty common thing, and you may not want to pull an additional library, but for now there's a solution and there's other things to take care of.
Yeah. No, that's really cool. Yeah, I wasn't really expecting even answers or things to be done here. So this is really awesome that you've made. I'm just thinking of things as I'm.
Yeah, no, it's been.
This is really, really fleshed out.
Yeah, no, this has been on my mind for I'd say maybe like a year or two now. because like I've had these issues running production Elixir apps, and these things were always painful for me. And if I thought to myself, if I were to make a library that takes care of these things, what would I want it to do? And that's kind of where I've taken this is what do I want to use in my own apps, and that's kind of where I've been checking off things from the to-do list. Is anyone curious to dive into the code base, or I can give like a brief tour if anybody wants?
Yes, I always like that. Also, for what it's worth, I have historically turned off metrics access to anything but the Prometheus that's running inside, or the Prometheus that's running in the cluster with me in Kubernetes, but I don't remember how.
Gotcha.
If you could like do it from, like, we've talked about this before, but you haven't talked to everybody else about it. Like the difference in kind of methodology that you're taking versus what other like Prometheus Elixir libraries have taken, and kind of how you architected it.
Yeah, sure. So the only other library that I've used is what was it called? I think there's the Erlang library that has the like the Elixir wrapper, and I think they're both written by Dead Trickster. Yeah, Prometheus Earl, and then I think he also maintains Prometheus X. Yeah, so he maintains both. Yes, I think so. This is what I've used in the past was Dead Trickster's libraries, and huge props to him. The libraries were great. They served me wonderfully. I think the biggest differentiator was I really wanted to embrace the Beam telemetry tooling, so telemetry and telemetry metrics. Whereas this is one of the first Prometheus libraries that was written for Elixir, and I don't think telemetry was a thing back then. So, I mean, he made some other decisions, but I think there's room in the ecosystem now for something that's built upon telemetry and telemetry metrics. And so with telemetry and all these Elixir libraries emitting all these events, it made sense to kind of make like a plugin style library, which is what I created, where you pick the plugins that are appropriate for your application. And given that there's a clear contract with these libraries as to what events they emit, if you have the plugin in place, you can subscribe to those events and capture metrics on them. So that's kind of the high level details as to why I thought there was room in the ecosystem for another tool, and not just cause that. And I think I've taken a pretty unique approach to coupling the dashboards to the app. Usually, like the Grafana instances are kind of treated as their own thing. The definitions of the dashboards aren't necessarily kept in any kind of source control. And in my mind, it's the dashboards are effectively like a DB migration. When you update the app, you also update the dashboard to reflect any changes that have been made to the events and the metrics that are being collected and displayed. So yeah, those are kind of the philosophy differences between what I've written and what Dead Trickster did.
I'm a big fan of you adding the dashboards to that source control and to the libraries. So thumbs up.
Thanks. Yeah, so he's also published a few dashboards. Beam dashboards. And I mean, I've used these in the past heavily, so definitely want to give props to what he did. But the problem is it was always a matter of me copying and pasting this JSON into Grafana, making some final tweaks, and like I always had to do these kind of like last mile adjustments all the time. And if I could save myself 15 minutes every time, it's worth the investment of like 4 months of work. So
Yeah, my solution to this was to spend a week writing KSonnet that would generate the dashboard JSONs in a Terraform, which is just another solution that isn't as good as what you've got here.
Oh, thanks. Yeah, there's the, I can't remember, but there's the way in Grafana to tell it, look in this like PVC and Kubernetes for dashboards already defined, and it'll automatically pick them up.
Yep.
So that's another way to do it. Yeah.
Yep.
But
And then you have a Terraform script that sets up your dashboard, puts them in there.
Yeah, I've gone that route too, and it's also painful. So I like the idea of just give me that one, give me that token, configure the host for Grafana, and just let the app talk to Grafana directly. So the only issue there being if let's say the app and Grafana are on two parts of the network that just don't talk with one another, you may have issues there. But I have never actually encountered that in production. Usually, if Prometheus can talk to your apps, and Grafana has to talk to Prometheus as well for fetching that data, they're usually probably on the same network, and they shouldn't have any issues. Did I answer your question, Anderson, or I kind of went on a tangent?
I mean, you didn't jump into the, well, yeah, you did, but like you also were about to jump into the code.
Oh yeah, I can do that. Yeah. Yeah, where am I? I'm here at the base of the app. Yeah, so the dashboards are all in priv. So these all get shipped when I make hex releases. So that's when you saw that tuple where it says where, what's the OTP app that you want me to look in the privdir for, and then what's the name of the dashboard. So if you're using all the first party stuff, it'll be colon PromEx and then comma the name of the dashboard. Let's say you've forked one of my dashboards or you made your own dashboard, then it'll be colon whatever the name of your app is, comma, and then the path inside of your privdir. But yeah, these are all just JSON definitions of the dashboards. One of the other things that templating is going to fix is currently I've hard coded the data source to Prometheus, lowercase p. If you, for example, have your data source in Grafana set to Prometheus capital P, that dashboard will be completely broken. So part of that templatizing work is making these dashboards so they don't depend on hard coded things that I have set up. They can work in any context. So yeah, those are just some of the things that need to be sorted out. But then as far as the app goes, so Promix itself, I think this module is the only one that has a macro, but this macro, if we open up, let's say there it is. So this is the definition of that sample app. So if I use Promix here, this macro will go ahead and generate quite a few functions, and it'll also set up the supervision tree for your for the Promix app. And part of that supervision tree is the dashboard uploader, if you so choose to upload dashboards. If you set up your own metrics server, that'll also be part of the supervision tree. If you have any manual metrics, that'll also start another gen server that sorts out the refreshing of manual metrics. So all that kind of all that machinery is all sorted out for you if you use the the macro there. So lots of work went into that. Yeah, and then once Promex gets started in the supervision tree, it'll look for all of your plugins that you have defined. So it'll go through this list, and then it'll initialize each of them. So if we go, let's say let's open up a plugin here. Let's go to the Ecto one because I just wrote that, so it should be familiar. But one thing to note: so all the dependencies in in Promex that require libraries like Ecto, there's always a checkup at the top, because I don't want to force the user to download every plugin's dependencies. That would just be ridiculous if you have to download, Broadway, Ecto, Phoenix, and your app doesn't use any of those. So all of those are actually optional dependencies in Promex. But if you attempt to use a plugin without having those modules available to it, it'll raise. So you'll get the appropriate error warning that says, "Hey, you're trying to use a plugin, but it doesn't look. You're trying to use the Ecto plugin, but it doesn't look like you actually have Ecto installed." So that's one way of trying to keep the package all together, because the last thing I wanted to do was maintain a separate repo for every single plugin. That would be god awful, and I didn't want to do that. So this is one way of keeping it nice and concise. But then each plugin has a behavior that it implements, and what it'll do is it'll specify what event metrics it's capturing, what manual metrics is capturing, and then what polling metrics it's capturing. So this Ecto plugin is only event metrics. This is the only function that's implemented. The default implementations of the other two functions are just empty lists. But what effectively I'm doing here is I'm taking in some of those init options. So let's say, well, we'll look at this line here, right? So my init options for this plugin are the OTP app and the repos that I want to set up metrics on. So with the Ecto repository pattern, you can actually have many repos running in your app, and Promix actually supports that. So if you have, let's say, a read replica and only one write, you can have two different repos and you can get metrics on both of those, and Promix will account for that. And actually, if we go to the dashboards here and we go to the Ecto dashboard, you'll see that this list is dynamically generated, and I can get metrics on the different repos here. But yeah, so those options are passed to the initialization functions, and since OTP app is a required configuration option, I'll raise on that. But I kind of just go through all those options, set up the plugin as needed, and then kind of go through all of the telemetry events that library provides, and then generate all of those telemetry metrics setup calls there. So let's say for the init function, or for the init metrics that Ecto emits, I'll capture like the last value for the pool size, the status, is it up or not, and the the timeout duration. And then for query metrics, I'll capture the idle time, the queue time, how long the connection sat in the queue, the decode time, the query time, so how long the query actually took to take place, and I can't remember what this one's doing. Oh, this is the number of results that are being returned. So some massaging needs to happen here, which is why my measurement and my my drop functions here need to be defined, so that I can kind of dynamically massage that data as it's being produced, and then publish metrics on it. But all the plugins follow the same style, where you have event metrics, polling metrics, and manual metrics. And these are all just telemetry metrics definitions, so that that library knows how to generate those data points. And so, like, if we go to like application, I think this one's mostly manual metrics, but yeah, same style. I'm kind of just attaching to telemetry events, capturing the measurements and the tags that I need for each data point, and that's kind of the value proposition with Promix. You don't have to ever do this. You'll get Ecto, Phoenix, Beam, application, Broadway, you name it. Like you'll have all these things sorted out for you, so you don't need to go through this this hassle ever again. Yeah, that's kind of it at a high level. I mean, I have the the metrics server, which is a standalone standalone server. We have a Grafana client here, which is a little messy. It's on the list of things to clean up. But yeah, there's some debugging utilities if you want to.
Finch.
Oh, what's up?
I said Finch.
Ah, yes, Finch
That's right.
is. Yeah, Finch is what I use for uploading, and then actually Finch also emits telemetry events. So there's a
Plugin.
yeah, there's a plugin here. Where's my list of plugins? I have a pretty busy list here. Yeah, Finch is down here. So I'll be adding a plugin for Finch as well here.
I like that Absinthe is at the top there. I did Prometheus metrics from Absinthe, and it was rough at the time.
Yeah, I'm kind of curious how I'm gonna approach this problem, because so Absinthe emits a lot of metrics, and there's also a lot of metadata associated with those metrics. I can't remember what's Absinthe called? The blueprint. They attach the blueprint as metadata, which is a huge data structure. So I'm kind of curious how I'm gonna pick that blueprint apart and figure out appropriate labels to attach to all these pieces of data. It's gonna be interesting. I think this will probably be one of the harder ones to write a plugin for. But yeah, that's about Promix in a nutshell.
I have a random question. What is doctor.exs?
Oh, Doctor. So that's another library that I maintain. So Doctor, something got in my eye here, sorry. So Doctor will go through your code base and keep track of your documentation coverage. So if, like, let's say you define in your doctor.exs file that you demand, 90% spec coverage, 90% function coverage, and 100% module doc coverage. It'll check your whole project to make sure that all of your modules adhere to those.
I love that a lot. That's actually my favorite thing.
Yeah, so it's
The
up
other
on
stuff's
Hex.
cool too, but I can use that one immediately everywhere.
Yeah, so I use this in a lot of the projects that I work on. Mostly because it keeps me honest. Like if I'm writing a library that other people are consuming, I like to ensure that I have good documentation coverage for that project. But yeah, this one's also up on Hex, and I think I ran it against Phoenix as it's in the README here, and you can see that Phoenix was they dropped the ball here on the spec coverage. Tisk tisk. But yeah, I use this one a lot as well, so definitely recommend it. But yeah, I don't think there's anything really else of particular kind of interest here. Everything else is pretty standard stuff.
You want to expand metric types? I just want to see what's under there.
Yeah, so that's those the event metrics type. Yeah, and I mostly just needed these for easy pattern matching, so I can perform different operations depending on the metrics type that are coming back. But yeah, there are some slight differences between the metrics types. For polling metrics, here we'll open this guy up. For polling metrics, you need to give it a poll rate. How often are you actually polling to gather those metrics? And then you also need an MFA, so module function arguments, for what function you're actually invoking at that regular interval. And that MFA will emit a telemetry event that you capture data for. Promix will intelligently set up your supervision tree. So if let's say you have some metrics that are being polled at 5 seconds and other metrics that are being polled at 10 seconds, it'll aggregate all the metrics that are polled at 5 seconds and emit all those events every 5 seconds. And then it'll aggregate all of the metrics that are collected every 10 seconds and then emit all those events every 10 seconds. So as opposed to having each plugin start its own 5-second and 10-second polar, it'll globally start a 5-second and a 10-second polar. And then from each plugin, it'll put the appropriate metrics in each kind of sub-process.
So I think we've exhausted everything here.
Yeah, I think we've pretty much covered everything that there is to talk about in PromEx. I can't think of anything else.
I've got a random question.
Yeah, sure.
Alex, for some reason I had you associated with AppSignal. Did you once work there, or were you just like a guest on their blog?
Oh,
or,
yeah,
am I just like misremembering?
Yeah, so I actually wrote a few of their blog posts. I think it was like 4 or 5 blog posts. Yeah.
Okay, cool.
Yeah, I didn't actually work there. I was just a guest writer. But they do operate in a very similar space because they're all about application metrics, and I think they focus on Elixir and Ruby. I think there are 2, maybe Node. I can't remember. But yeah, I think they've done some work in the telemetry space, like Elixir telemetry.
I have a broad question, which is, has anyone here done anything tracing wise aside from like Redbug or other Erlang level tracing stuff? I know we mentioned tracing.
I have not done anything with Elixir and tracing.
I have not either, and I'm sad about that.
It's on my to-do list.
The ever-growing to-do list. I know how that goes. Yeah, it would be interesting to get into that, the tracing side of things, especially now that I think Grafana has the ability to surface Jaeger traces, I think, as part of Grafana. So it would be really cool to get kind of all 3 pillars of observability in Grafana, because you could do logs with Loki, you could do Jaeger traces, and then you could do Prometheus metrics. That would be pretty cool to get all of that running in Grafana.
And it's a site cheaper than Datadog.
Yeah, that too.
The only digging I've done into that has been with Zipkin, and Tristan Slaughter has the Open Telemetry Zipkin exporter, and so that's a thing out there under the Open Telemetry beam. It's one of the ones to maybe take a peek at.
Okay, yeah, I'll take a look. Yeah, maybe I'll write a blog post early next year.
I'll read it.
Give the blog some love. So out of curiosity, what do people use for logs and metrics currently? Just to kind of get a sense for the tooling in the ecosystem. I'm guessing most people are on like Elk or something.
In my last job, we used Grafana with InfluxDB, and we also used Kibana for the logging.
Okay.
I'm got an stack for logs on a Java project, but
you lost me at Java.
Me too.
Yeah, we are AppSignal and Datadog, and recently migrated from Timber to Logflare. And I'd love to see some consolidation and simplification there. So, this talk's been really, really exciting in that arena.
Cool. Glad to hear it.
And Wombat is what we've been using. Has been the primary thing for gathering any of that sort of thing at this point.
Well, it's sad that Oliver left already because he was looking for people that had used Wombat.
Yeah.
Do you need a commercial license for Wombat, or can you?
You do, yeah.
You do, okay.
Yeah, and yeah, it's a mixed bag. It's definitely you're initially stuck with nothing. And so whenever you're building out, and the idea of not having to do all of the work had put, Wombat way ahead, because it's like, all right, well, that saves you a lot of time of dealing with things. With things like, this, a lot of what you get inside of a product like Wombat, you start wondering about it, and then the things that are coming in just right out of the box inside of Phoenix with the live dashboard.
Mm-hmm. Yeah.
And so it's like the community is just caught up with, is basically edging that product out, I think.
Gotcha. Yeah, the only bit of Phoenix Live dashboard that I don't know if that's ever going to be a priority for the project is that long-term persistence. It would be interesting to have it maybe persist data somewhere and then make calls, but I mean at that point they're kind of reinventing Grafana, so I don't know if they'll ever kind of take the library in that direction.
One of the most interesting things about the way that Wombat works, and it's a plus and it's a minus. It can really burn you. It's a lot harder than you're going to get burned here on multi-version things. But when you hook up a Wombat server, and you say, "Hey, connect to my cluster," it will attach to each node and then ship beams to each of your nodes. And so it's running plugin code. It's doing just network loading. Code loading, and then those agents are then running on each of your running nodes, and basically sending data back and forth. And so that works really great. It's efficient. There's a whole lot of efficiency they can get out of that, up until the point that you have multiple versions of things that conflict, and it gets you into a really nasty, scary place there.
Gotcha. Okay, that's interesting.
Yeah.
I think the versioning issue is it's a tough one, because I think I'll have the same issues with the blue-green deploys, where you have like old versions of the dashboards and new versions kind of competing for presentation in Grafana. So that'll be
yeah. It's a whole world. It's like you're trying to write a Stargate script or something, because you've got these alternate timeline, alternate time machines and alternate universes, and all of it happening at this, and you've got to somehow make something that makes logical sense for the different versions of the software that can run as you fall forward and back and so on. So. There's one other thing, so you're talking about on the side with tracing. There's definitely Erlang tracing things that would be interesting to fit in there. And then this is pretty far removed from, I don't know, it's a kind of but I'm thinking of things like the tools like that Fred Abair Recon.
Yeah, Recon Trace. Yeah,
and so that's a part. Some of the Recon kinds of things are in Wombat, built into that tool. Recon is its own thing, which is awesome, and we've built a bunch of things like Recon that are specific to our platform that do a lot of things. And so that's this other territory of where this whole ops, this whole DevOps side of things fits in, the observability. And so in, DevOps handbook, everything you're talking about observability is like this really sweet chapter in the DevOps handbook. And then there's another chapter and there's another chapter. And it'd be really fun to see this whole, the DevOps handbook basically implemented in Elixir, chapter by chapter of all these tools to help us be, to get our jobs done.
For sure. I think like the Elixir loggers is one of the best I've used in any ecosystem, like the one that comes out of the box with Elixir. And I think, what was it, Elixir 1.10? We got structured logging like out of the box. You don't need any additional libraries to have structured logging in Elixir. So I think that pillar is pretty well built. I'm really hoping that Promix becomes that metrics pillar, for the ecosystem. But yeah, then that third one, tracing, I think we still need there's still some work to be done there, I think. But I've never actually heard of recon trace. I've used recon in the past. It's ridiculously useful when you have to figure out what's leaking memory. But I've never heard of recon trace before, so I'll have to
Recon trace helped me find a essentially an infinite loop that was not not enough to blow a stack or anything, but it was enough to make my web server basically unusable in certain conditions.
Oh, interesting. Yeah, I'll have to read about that. Yeah,
my problem with recon trace is my Elixir stuff doesn't actually go wrong frequently enough for me to be familiar with it, and so every time I have to trace something, I have to read this page right here.
That's like when you need to write a bash script and you need to like peruse the same Stack Overflow posts and figure out how to write bash again.
Set dash E.
Yeah, one great thing about recon trace is it has like sensible defaults, so you won't crash production. By trying to trace every call, it kind of like either times out or just doesn't trace as deep as everything is.
On a related note, guess what I did that led me to find out about recon trace?
What's that?
It was bringing down production because I traced too much stuff.
We've all been there. We've all done that. Yeah. I mean, in the same line of tools, what's the other one? Observer CLI is also ridiculously useful.
Yep.
That depends on recon, I believe. That's how I kind of got that in production. We put Observer CLI. That depends on recon. So now those things are available in production.
Oh, I didn't realize that this depends on recon, but I guess that makes sense. That it probably needs some of that tooling. But yeah, this has been ridiculously useful. Yeah, I just get like a remote IEX session in like a container. Bring up the CLI observer, and then you can take a look as to what's going on. So that's been really useful for production ops related stuff. It looks like you can write your own plugins too. Maybe Promix will have to have like ASCII charts in Observer CLI.
Obviously.
The obvious next step.
All right, I think that probably wraps it up. We have 7 minutes technically left in the 2-hour block. This is the longest we've gone, and I've enjoyed every moment of it.
Cool, that's awesome.
Thank you,
We
Alex.
lost